You aware with all operations of matrices, because you know, only then you will understand. If you don't know, then you know you need to cover all of operations like addition, subtraction, multiplication, division of vectors. That is why I'm asking.
Yes, ma'am, I know the addition, subtraction, multiplication of matrices.
Okay, that's good. Just few seconds. We are going to start. Just give me few seconds. We are going to start. Eigenvalues and eigenvectors. Let So remember one thing always, we always find eigenvalues or eigenvectors or both for only square matrix. Okay,
Okay.
because to find eigenvalues or eigenvectors, we need to find determinants. As you know very well that we can find determinant only for square matrix. That is why. Okay.
Okay,
So
ma'am.
we find always eigenvalues and eigenvector for square matrix. So let us take accordingly let A be any square matrix. Then following step to be followed to find eigenvalues and eigenvectors.
Okay, ma'am.
I'm telling you which step. Okay, we will do in detail. And
Okay, ma'am.
eigenvectors. First step, step one. Form matrix A minus lambda into I. This is first
Fine.
step.
Okay, ma'am.
Step two, find determinant of determinant of A minus lambda into I. Third step, put Determinant of A minus lambda into I is equal to 0.
Yes, fine.
And find the equation in lambda. Okay, we will get an equation in lambda. Okay, when we
Yeah.
put this determinant of A minus I into lambda is equal to 0, then we will find an equation in lambda. So,
Okay.
equation the equation of lambda is said to be characteristic equation. Sometimes they can ask you find characteristic equation. So you need to know equation in lambda is said to be characteristic equation. Okay.
Okay,
So the
ma'am.
equation of lambda is said to be characteristics equation.
Okay, ma'am.
Next step is fourth step. Yes, we have done till third. Next step is fourth. Solve the characteristic equation for lambda. Values of lambda are eigenvalues.
Okay, ma'am.
Next step. Till here, we will get eigenvalues. Now we have next steps to find eigenvectors.
Okay.
Okay. Next step is fifth step. So step 5. To find eigenvectors, form the following equation. A minus lambda into I into x is equal to 0. Where and put value of lambda which found earlier. Here we will put value of lambda which we got, which we found above. Okay. Here we found here value of lambda. We will put here. Okay. And where x is equal to having x1, x2 means we can have any number of like components here up
Yes,
to
ma'am.
xn is an eigenvector. And right side O is zero matrix or null matrix. And O having all elements 0, 0, 0, 0, and up to so is a zero matrix having order same as of x means O will be the column matrix according to like number having all elements 0, 0 according to x means if we have three elements in x then also we will have here three elements. If we have two elements then we will have here 2, 0, 0 two times. Okay, so that is the
Yeah.
meaning. Are you getting me?
Yes, ma'am, I get.
Good. Now let us do one question.
Yes, ma'am.
Next next step is sixth. Step six. Solve our equation or solve a minus lambda into I into x is equal to 0 for capital X. And capital X is an eigenvector. Okay. So
Okay,
in
ma'am.
this way, we can find first eigenvalue and then eigenvector. Okay. For that eigenvalue. You got?
Yes, ma'am, I got.
If you have any doubt, then you can ask me. I'll repeat. Okay.
Okay, ma'am.
So let us do one question to understand this well.
Yes, ma'am.
Question is find eigenvalues and eigenvectors for the following matrix. Eigenvalues and eigenvectors because for each eigenvalue we have a different eigenvector. Okay. So we
Yes,
have
ma'am.
first of all we are doing for 2 by 2 order square matrix. Then we will do for 3 by 3. Okay. So
Yes,
let matrix A is equal to having 7, 2, 3, and 1. So let us find the solution.
yes, ma'am.
Step 1 is just form the matrix A minus lambda into I. Okay. So to find eigenvalues, because first of all, we will find eigenvalues. Then we
Yes,
will
ma'am.
find eigenvectors for those eigenvalues. Okay.
Okay, ma'am.
Eigenvalues. Put determinant of A minus lambda into I is equal to 0. We need to put this. Okay. So
Yes, ma'am.
form matrix A minus lambda into I.
Yes, ma'am.
So let us find it. A minus lambda into I, which is equal to A is having 7, 2, 3, 1. Minus lambda into I is identity matrix of the same order of A. So now let us find it. It will be 7 minus C. We are multiplying this lambda here. Okay, let us do one more step. 7, 2, 3, 1 minus lambda 0, 0. Lambda. Now let us subtract corresponding elements of this from this. Okay.
Yes,
So
ma'am.
7 minus lambda, 2 minus 0, 3 minus 0, and 1 minus lambda. This is A minus lambda into I.
Yes, ma'am.
Now we will have 7 minus lambda, 2, 3, and 1 minus lambda. This is A minus lambda into I. Now let us find its determinant and put it is equal to 0. So A determinant of A minus lambda is determinant of A minus lambda into I is equal to, let us take as 7 minus lambda, 2, 3, and 1 minus lambda.
Yes,
Now
ma'am.
let us find its determinant. So we will take it as 7 minus lambda into 1 minus lambda in minus 3 into 2. So let us multiply it. 7 lambda minus 7 lambda minus lambda and plus lambda square minus 6. You got? It's a step you got?
Ma'am, why you write 7 lambda in a second?
See, 7 into 1. Sorry.
Yes,
Yes,
ma'am.
yes. Yeah, yeah,
Yes,
yeah.
ma'am.
Sorry,
That
my mistake.
talking
Yes,
about
I
that.
have written twice. Yes. 7 into 1,
Yes,
7, and 7 into lambda.
7 lambda.
Yes. Okay.
Okay, ma'am.
Then we are multiplying this lambda with 1. So we got here minus lambda. And then multiply lambda with lambda.
Yes, ma'am.
Then we get this minus 6. So let us simplify it and write in order lambda square minus 8 lambda plus 1.
1.
Okay. And this is determinant of A minus lambda into I. To find eigenvalues, we need to take it
Yes,
as
ma'am.
0. Put determinant of A minus lambda into I is equal to 0. So we can put this lambda square minus 8 lambda plus 1 is equal to 0, which is characteristic equation. This equation is characteristic equation,
Yes, ma'am.
which is characteristic equation. Now we need to solve this equation for lambda, okay? Now we need to solve this. So let us do. By using quadratic formula, remember quadratic formula? I'm telling you.
Okay, ma'am.
If we have quadratic equation, we are taking here standard form. Standard form, and also we are taking equation in terms of x. Bx plus c is equal to 0. Then value of x is equal to minus b plus minus square root of b square minus 4ac. This formula we use in 10th standard over 2a. But here we need to solve this quadratic equation. That is why we are using. Okay. And
Yes,
one
ma'am.
more thing, you can share me your question which you got from college. Okay. Like you, if you have any book, any assignment, anything else, because I need to see your pattern of question in your exam. That is why. Yes,
Okay, ma'am. I will share it.
you had today like maths exam, right? Mid-sem.
Yes, ma'am. I had math exam.
Yeah, you can share me that also. Okay, I can see the pattern.
Okay, ma'am. I will share it.
Yeah, you can share me right now also, because if you have any question related to eigenvalues, then we can do during the class. Okay.
Okay, ma'am. I am sharing you right now.
Yeah.
I sent it.
See, in third question, you have find the characteristics roots of the matrix. Characteristics root means eigenvalues. Okay, they can give you the same thing by changing the name. So characteristic roots of the matrix is same as. Why? Because this equation is characteristic equation. So it's like the value of lambda will be the characteristics roots. Okay.
Okay,
So
ma'am.
I'll write here. That is why I was asking if you can share me your mm, paper so that we can understand the pattern,
Yes,
because they are
ma'am.
not using direct name. They are using another name of the same thing. So I'm writing here eigenvalues. Uh, we can edit it. Eigenvalues, and we can say characteristic roots also. Okay. Another name is characteristic
Characteristic groups.
root and eigenvectors. I'll share you this whiteboard as PDF to you. Okay. Share me your mail ID so that I can send you this whiteboard. So this is
Okay, ma'am.
quadratic formula. Let us use in our characteristic equation. Okay. To solve it.
Yes.
So let us compare the above equation with this standard form. So we will have here 1, A as a 1, B as -8, and C is 1. Okay. So
Okay, ma'am.
here A is equal to 1, B is equal to -8, and C is equal to 1. So now let us find value of lambda. Minus B. So minus this minus of formula, but we have negative value of B. So let us write here -8 plus minus square root of B square. That means -8 square minus 4 into A into C over 2 into A. Because A is 1, that is why we are taking A as a 1 everywhere. So minus minus, it will become plus. This minus and this minus makes it plus. And plus minus of formula, square of -8 will be 64 minus 4 over 2. So 64 minus 4, then we have 60 in a square root over 2.
Okay, ma'am.
So how we can find this? So 12 fives are 60 and 4 threes are 12 into 5. Then we can take C. We can take square root of 4 and can take this 15 inside. Are you getting me?
Yes, ma'am.
Or we can
4.
take 15, sorry, 15 4 also. Because
Yes,
15
ma'am.
is not a complete square and 4 is complete square. So we can take 2 as a outside. You know why? Because in a square root of 60, 60, we can write it as 4 into 15. So square root of 4 is 2 and can write as. Okay, so square root of 60 can be
Okay.
written as. Okay.
Okay, ma'am.
Over 2. Let us take 2 as a common. So inside we have here 4 plus minus square root of 15 over 2. So we can cancel common as, and left side we can write value of lambda. So let us take one time minus and one time plus. So lambda is equal to 4 minus square root of 15 and 4 lambda is equal to 4 plus square root of 15.
Okay.
Okay. So these are eigenvalues. So
Okay, ma'am.
eigenvalues are, we can conclude, are 4 minus square root of 15 and 4 plus square root of 15.
Yes, ma'am.
Got it? Now we need to find eigenvectors. Okay. So to find eigenvectors, put A minus lambda into I into X is equal to 0. O. Null matrix, that's zero matrix. So first of all, we will find this A minus lambda into I. For
Yes.
we can do for anyone. Okay. One I'll tell you and another one you will do yourself. Okay. So I'm finding eigenvector for this value. Okay. For this value, you can find yourself. Okay. In similarly, okay. In similar way, you can find. So for lambda is equal to 4 minus square root of 15. Let us find it. A minus lambda into y. So A is 7,231 minus lambda is equal to 4 minus square root of 15 into identity matrix and 7, 2, 3, 1, and take this inside 4 minus square root of 15, 0, 0, 4 minus square root of 15.
Yes, ma'am.
Let us take here a minus lambda into I. A minus lambda. A minus lambda into. Now subtract corresponding elements. So we have 7 minus 4 plus square root of 15. You know why? 7 minus this minus and this minus make it plus. Okay?
Yes, ma'am. Yes, ma'am.
And this will be the same because 0 is nothing. So because in from 2 we subtract 0. So obviously write 2 itself. And 3 minus 0 is 3. And 1
Three.
minus 4 plus square root of 15. You got?
Yes, ma'am, I got it.
So a minus lambda into I. So 3 plus square root of 15, 2, 3, and minus 3 square root of 15. This is a minus lambda into I.
Yes, ma'am.
So now let us find eigenvector. Take this a minus lambda into I into x is equal to 0 matrix. So a is 3 plus square root of 15, 0, 3 minus 3 plus square root of 15 into because we have like matrix of 2 by 2. So let us take this of like having x1, x2 because we have only two components because of 2 by 2 matrix, and take same number of elements as 0, 0 in 0 matrix, or we can say null matrix. Are you getting me?
Yes, ma'am.
So now just multiply this first row with first column, then second row with first column, 1 by 1. So 3x 3 plus square root of 15 into x1 is equal to 0 because first element we multiply with first plus second with second. So second is 0. That is why we have this is equal to 0.
Okay, ma'am.
So then x1 is equal to 0 because we take this on right side and just divide, and now multiply second row with column.
Ma'am, can I say something?
Yes,
मैम यू राइट 3 प्लस रूट 15 मैम उसके आगे आपने जीरो लिखा यू राइट जीरो ऑन दैट बट
I'm
देयर
not
वाज
getting
2
you. Can you repeat?
मैम नहीं मैम मैं कह रहा हूँ आपने यहाँ पे जीरो लिखा है मैम यहाँ पे 2 नहीं आना चाहिए था
Let me check it again. Yes, yes, I forgot. Yes. Yes. Sorry, my mistake. So let us multiply x2 with 2 is equal to 0. And
यस
now
मैम
multiply second row with column. So this is 3x1 plus, minus, or we can take plus also by taking as minus 3 plus square root of 15 into x2 is equal to 0. So from here, you can find relation between x1 and x2 by taking by taking any equation, how you can take it as like 2x2 is equal to minus square root of, sorry, minus 3 plus square root of 15 into x1. Or I'm writing below of that. Or we can take second equation also. We can solve any one. Then we'll put value of any variable. Like if we solve this equation, we will find a relation. Then we'll put that relation in our equation. Okay.
Yes,
How?
ma'am.
Let us take 3x1 minus, or when can take plus, or can take like this, minus 3 plus square root of 15 into x2. Okay. And from here, and from first equation, we can write it as 3 plus square root of 15 into x1 is equal to, or can write it as also 2x2 is equal to 3 plus square root of 15, and having minus sign because we are changing the side, into x1. Okay. Or we can take, because we can put here value of x1, okay, by taking value from first equation. Okay.
Okay.
X1 will be minus 2, because we have minus, so we can take on other side, and 3 plus square root of 15. We can take value